Welcome to the project demonstration of diabetics prediction system by using machine learning algorithm along with decision tree and J48 dataset we are using here. So the decision tree is the main machine learning algorithm to predict the diabetics. So there we are using the 6 types of diabetes predictions in type 2 only. So that is excellent. First is normal basic stage, and the next stage is normal, and the next stage is borderline, and the next stage, fourth stage is pre-diabetics, and next diabetics, fifth stage, and the next last is a dangerous one. So these are the data machine learning decision tree outputs when we are providing the sensors data input to that. So what are the sensors we are using in our project is, one is a temperature sensor from this, and next glucose levels from this sensor. So these two are providing the analog data. So we can't provide the analog data input to the Raspberry Pi 3 directly, as it doesn't have the analog to digital converter inbuilt. So for that purpose we are making use of this Arduino Uno, so which will take the analog input from A0, A4, A5 pins, and it will convert that analog to digital initially in the programming, and then after the same data will be converted to the serial. The serial data consists of how much of glucose levels are present and what is the body temperature. So these strings will be arranged in serial data and sent to the Raspberry Pi at the receiving pin. So from there the Raspberry Pi will check the first input is which mode you have now, whether a dataset mode or a sensor mode. So when you keep that in sensor mode, it will read the data, so-called data which are received from the Arduino Uno, and then it will take some samples and it will arrange some dataset again, and after that the dataset will be given as input with compare with the which is already stored in the dataset. Okay, so the dataset is loaded by using the sklearn module. Sklearn is a module which comes with defaultly decision tree algorithm as well as random forest algorithm. So in our project we are making use of decision tree algorithm with J48, and that will provide us the output of a disease name directly, as we described the disease name 6 types of diseases. So that will provide that and displaying on the LCD screen. So here the Raspberry Pi comes with normal empty one. Then before writing the code, so in this this black color we can see that. So this black color is a memory card. So which we are using is 32 GB class 10 SanDisk memory card. Initially we will take that. We load a Raspberry Pi OS. So the OS version is Raspbian Buster OS 32 bits. So initially we need to load that OS. Then after we need to install the respective modules. So those modules are like Python, OpenCV already comes with that. And the next sklearn we need to install. It will come with the model files along with or decision tree and random forest algorithms predefinedly comes with that. And the next we need to copy some data sets. Means when you are reading the input from the sensor, that's fine, okay, but when you want to test it, train dataset already, which you have already collected the dataset from the hostels from different patients. So those datasets we have loaded here 6 types. So that dataset can be selected from this keypad, 4x4 matrix keypad. By selecting the dataset, instead of reading the data from the sensor to the Arduino Uno, it will download the same dataset which you already placed inside this memory card. It will read the dataset again. Then it will compare with the stored datasets, and the output from this decision tree is directly of disease name, and that will be displayed on the LCD screen. 6 datasets we are using. Those are downloaded from the Kaggle, which is freely available for us. So that dataset already stored inside that is dataset 1, 2, 3, 4, 5, 6. So coming to the interfacing connections, sensors interface to the A0, A4, A5. Yeah, transmitting pin of our Uno board is connected to the receiving pin, that is the 15th pin of our Pi 3. And the next LCD interface gets pin number 9, 10, 11, 17, 27, 22, and the keypad interface gets 5, 6, 9, 13, 27 and 21 and 16 and 15. So that was the interface connection for the keypad directly, and 12th pin for the LED and 18th pin for this switch for the selection of this one. So when we on the power supply to this Raspberry Pi, it start booting the OS like our laptop, and once the OS was booted successfully, then this light will on and off 2 times, and on LCD display we can see the project name directly. Right, just on the power supply to that, and there we can see the lights here. So on this one we can see the sensors, temperature sensor as well as a blood glucose level. So let me explain you how this glucose level sensor can detect the glucose levels in milligrams per deciliter. So LED on and off, and This is the welcome message displayed on the LCD screen, right? So now coming to the sensor part. Temperature is directly like it will check the surface temperature. Based on the temperature varies, the resistance varies, parallel the voltage varies. So and coming to this glucose sensor, when we place the finger, initially it will check the finger presence using IR sensor, and the next it will go with the red LED, which comes with a 7 milliamps of current only. And when the so-called red LED transmit the LED red light, then the finger consists of the blade, systolic and diastolic one. And in that case, when the red LED fall on the red blood cells, based on the quantity of the red blood cells, we will receive the receiving voltage that will be identified by the photodiode, and the receiving voltage will be measured by the unoport. Means if the finger filled with full of blood and is no blood, then the system will get the different voltages. And when I'm getting the maximum voltage, that's indication of finger was filled with the blood, as the reflection is more due to the red blood cells. And in the next case, we have already trained some data sets inside the Arduino Uno with samples, so that indicate the if it is normal glucose levels, then the blood thickness is very less. When the glucose level is high, the blood thickness is more. So based on that differentiation, we are going to identify the approximate blood glucose levels. So that will be sent to the Raspberry Pi directly. Now let us see initially go with the dataset mode, and display the dataset mode, enter the number from the keypad. Just enter the dataset 1. Right, so this is prediction now. And then after analyzing the dataset, based on the dataset size, the system will take time. So the one is for the pre-diabetics one. So if we enter the 2, right, based on that dataset memory and dataset size, so the system will take more time or less time based on that. Second dataset is a high level. So whenever that so-called diabetics levels are higher than the 280 or 250, then it is coming under the dangerous level, and high 80 or 90 below, it's coming under the excellent. So it's diabetics dataset, which we have already from the dataset 3. And this is the breadboard actually. So this one is you can see on the LCD screen. Meanwhile explaining this comparison, it's a borderline, and the breadboard is used to, right, if there's any junk data, just we need to restart this. Right, so this is the breadboard to distribute the 5 volts power supply, as we have the 5 volts power supply slot at this Raspberry Pi section, and it's normal. So the 5 volts is given at this slot, and parallelly we are distributing that throughout the inputs and output modules. So in our project, mainly input modules are 2 sensors, temperature and glucose levels, and keypad, 2 sensors, 1 keypad and switch. And output modules are LCD, LED indication. So these are the output modules in our project. So dataset mode is completed. Now let us see the sensor mode. So place your fingers gently inside that. No need to press hard on the sensor. Just place it gently, and it will take some samples. Once the successful samples collected, then only it will display the calculating the disease and displaying on the LCD directly. And main thing is, while if you are placing the finger on the sensor, you should have the clean on the skin, otherwise it won't get the readings in faster manner. Right, so my was 96 and analyzing. So when you're displaying the analyzing, just you should take out the finger. Now it is asking for the next input from this one. So excellent for that. So in this manner we can place a different persons, and we can collect them. So it is say there only my last reading. So when another person places a finger, then it will take his samples. So only the thing is, when it is showing the analyzing, just you should take out the finger from the sensor.